So I got this 150 watt LED light fixture. It's a UFO. This is a different driver, but I'm just using that. It's a 70 watt driver, 100 to 264 or so. It says weird Chinese deal. I'm gonna feed it DC. It actually runs. I've already tried it. Runs off like 40 volts, which is pretty interesting. So when I cut that on, and about 43 volts DC, that driver is taking. It's a little over 2 amps, so it's about 40 watts or so. So obviously don't need the driver. That's just funny how that works. Now I'm gonna try to get this guy going. Done it before. I gotta crank the voltage all the way up. So cut that on, and the output voltage is about 600, something like that. So these are not always easy to get going. Alright, it just ignited. I didn't catch it, but so once it ignited, and see what happens, that voltage drops down real low, and it's going to start climbing, reaches little dips and peaks where it'll kind of stop and go back down, and stop, go back up again. But in this case, I'm already pushing 40 watts, whereas in the past I've only pushed about like 20, 24 watts. So this is actually going to get full bright. Don't want to run it for too long like that because I've been touching all on it. So see, it's just voltage is steady rising. And current's going up now, so it's getting up to like 4 amps, so creeping up on 80 watts. The voltage is starting to sort of go back up again. Current slowly climbing up to that 4 amp mark. Bulb's getting pretty bright now. So it stopped at about, now it's going back up. It's about 4 amps. So that's 100 water. So it probably would eventually start pulling about 100 watts or so. Creep up to about 1 more amp after a while. So it does get a little brighter than how I was running them before. It does get quite a bit warmer. Feel some heat coming off that thing. I'm not quite sure what it might end up settling at after a while, but I don't know, that might be about what it's going to push. It looks like that's about what it's going to settle at, about 80 watts. So you see it takes that initial about 600, maybe a little bit more or so, to get it ignited. Then the voltage drops down real low, climbs back up, maybe about a nominal, I don't know, 80 or 100, maybe something like that. Yeah, not too bad. Cut it off. See that thing getting pretty hot. And yeah, the bulb's real hot, so I don't know, with me touching all on it, I might end up cracking it or something, but it's not pushing the full wattage, so maybe not. Now, just because, I'm gonna see what this voltage does in water. So just got a long bolt and a drill bit, just kind of chilling in there randomly, kind of see what high voltage does. So if I cut it on about 70, I see a little something going on there, but pulls a couple amps, so that water resistance there is something that the ZVS doesn't mind putting current through. Turn the voltage up. Let's put it about like 100. Let's see, do about 200. So you can see at which point the current really goes up. So we're at 4 amps, 80 watts, about 130 volts DC. So yeah, it really starts working it. Really starts pushing that juice up in the higher voltage. And current picks up a lot more if I bring them closer. Or if I bring the voltage even higher, it really starts pulling a lot of current. Just kind of interesting. Doing that though is an example of this regulation that ZVS driver is getting hot doing that. I can feel the heatsink hot because this is doing that such a high rate of switching. But normally if I was to just come, you know, straight off the ZVS and do that from the battery, vary the voltage and whatnot, highly doubt it would do that. Transformer, you know, doesn't mind that, but the switching itself, yeah, it's kind of struggling. So now I've just got a regular incandescent. So if I cut that on at about the 68 volts, kind of illuminates dimly, and I can crank it up. So at about 120 or so. So let's say that right there is supposed to be full brightness, and that's actually pulling about 60 watts to do that. So it's not very efficient. Typically, normal straight battery to ZVS, that probably would run fairly efficient, but in this case, it's just not so much. So I'm gonna crank it up so I can actually bring it about 200 volts, and it doesn't want to pop, but I can push it up to about 80 watts or so. So I probably could pop this fairly easily with this supply. Not sure if I want to do that. So yeah, that can actually withstand a good amount of voltage. That's pretty impressive. All right, this was the first circuit I made. Somewhere over here, this guy, and you know, used the PWM, buck driving, you know, CC, CV, different types of methods to charge caps at some regulated level. Now that I've put this together using Teslaundmehr's idea with the comparator, I don't really need that other circuit anymore, because this is going to allow me to set an output voltage and charge caps up to that voltage. So again, current limiting that is how I would slow the rate of charge. But in this case right now, it's just got a battery in there, and I just put that in there temporarily because I want to take it to work and maybe try to drive some small VFDs. Not actually drive them, but just power them up. And the point there is, you know, most modern variable frequency drives now have terminals that will give you access directly to the DC bus. So long as it doesn't have too much of a load, you know, a bunch of large fans, some drives will have that. You know, they'll have really small value bleeders, things like that. In that case, trying to do that is going to pull a lot of power. A lot of drives are not going to give you that problem though, so just kind of quick power up, parameterize it, reform the capacitors, whatever. So meter hooked up. So with this guy, the max voltage I can get is about 490, right? 480, 490 DC, about a 15 volt battery. So while that still works, that's not going to be the final way I'm going to drive this. Now I need to make this ammeter work in line with the output. That'll actually let me see what the leakage current is into whatever capacitor I'm trying to reform at the time, if that's the goal. So all I did was I just took my high voltage indicator and I threw that across the bleeder. So that's not going to be loading my output at all times, only when I bleed the capacitors, and then I can watch that dim down. Basically what I need to do is get this on the output in a way where it's switchable, right? It's just that simple. You're going to be pushing way more than 5 milliamps initially. What I want to do is switch this in line with the output once the capacitor has reached its whatever voltage that I want to leave it at, right? So that's the only thing there. If you're doing this, I guess you got to keep in mind that you just can't leave it on at all times. You're going to have to switch it in and out some type of way to avoid, you know, burning that thing out and whatnot. But yeah, that's pretty much it. Maybe see what it does on a drive. I'm not going to show too much, but got this familiar drive, got a battery in it. That's all that it is. Just a battery. Got this Yaskawa drive, little small drive, 480 volt drive. Got my output voltage set. I'm just going to cut it on and see. It is about 380 something. Drive comes on.
about 30 milliamps is pulling to keep the drive on and maintaining that output voltage. It's the battery voltage on the supply. So it's just going to sit there and reform those caps if they need be. So we're pulling that, and I can sit here and fidget with the drive here without actually having to plug anything in. So it's pretty handy, right?